Hi, I'm Mark Erickson, and today I'm very excited to share with you about modern Redux with Redux Toolkit. A few quick things about myself. I am a senior front-end engineer at Replay, where we're building a true time-traveling debugger for JavaScript applications. If you haven't checked it out, please do so. It is a great tool, and it can save you a ton of time while debugging. I'm known for answering questions pretty much anywhere there is a text box around the internet. I collect interesting links to useful articles and resources and libraries, and will happily share those around. I am a writer of extremely long blog posts, mostly about React and Redux. And I am a Redux maintainer. I've written most of our docs tutorials and usage guides, and I'm the creator of Redux Toolkit, React Redux version 7 and 8, and I helped guide the React Redux Hooks API. But most people know me as that guy with the Simpsons avatar. So let's talk about Redux Toolkit. First, let's talk about Redux itself. There's been a lot of complaints about Redux over the years. Things like it's too hard to configure and set up a Redux store, or you have to add a bunch of extra packages to it in order to do anything useful. It's very easy to make mistakes, like accidentally mutating the state. And then there's my least favorite word of all time, boilerplate. And these have been a lot of very recurring complaints. And when people say boilerplate, it's things like having to write action type strings and wrap those in action creator functions, or write a bunch of object spreads and array concats in order to do immutable updates, or the idea that you have to split Redux logic across a bunch of different files, or multiple steps in order to get a Redux store set up. And frankly, these were all very valid concerns. So it's worth taking a step back and asking, why did all this extra boilerplate even exist? And one answer is that this is kind of built into the idea of Redux itself. Redux deliberately adds a level of indirection to the idea of updating your state. Dan Abramov said early on that Redux is not designed to be the most performant or shortest way to write state updates. The focus is on making your code predictable. And on top of that, there are additional Redux usage conventions which added more code that you did have to write, like this idea of consistently using action creator functions everywhere, or writing your action type strings as separate constants, or things like selectors and thunks and so on. In addition, while the base library doesn't require some of these things, there are a number of additional rules in ways that you are supposed to use Redux. On top of that, the JavaScript language is mutable by default, and so you have to write extra code in order to get correct immutable updates. And finally, the Redux library itself was always designed to be a very small core that was going to have an ecosystem of add-ons to do additional work. And that means that you have to configure the Redux store with the exact set of options that your own application actually needs. Now, I do think we can kind of divide this up into a couple of different levels, and I like to describe this as inherent complexity versus incidental complexity. Redux has inherent complexity that is part of its design, and specifically this idea of dispatching an action that describes what happens instead of just saying, state.value equals 1, 2, 3. That is a key part of Redux's design, and if you take that away, it's not Redux anymore. But other complexity is not required. It's not something that is that you must do in order to use Redux. So, for example, this idea of splitting up Redux code into folders by type was never a thing. It's not a thing that you have to do in order to use Redux, or using object spreads, or having separate action type constants. Now, to be fair, these are patterns that we've always shown in the docs, but they weren't strictly necessary to use Redux. So, what if we could find a way to remove all this incidental complexity and make Redux easier to learn and use? So, That's why we created Redux Toolkit. And this was really inspired in a lot of ways by React App. For years, React tutorials often started with, let's spend 15 pages learning how to configure and set up Webpack and Babel before we even write our first line of React code. And React App simplified a lot of that process by providing you a good build setup out of the box with some standard defaults. So Redux Toolkit was designed to be the same kind of a thing for Redux. And we had several goals in creating it. We wanted to simplify most of the common Redux use cases, provide some good opinionated default setup out of the box, minimize the amount of code you write by hand. We don't want to hide the fact that you're using Redux. We just want to make it easier to use. Also, it should be opt-in. You can add it incrementally to an existing app or start a brand new project from scratch using just Redux Toolkit. And we wanted to make sure it had a really good experience for TypeScript users. When we first put it out, it was actually called Redux Starter Kit, but we renamed it because there was some confusion. People weren't sure if it was like a boilerplate repo that you would clone or if it was only good for beginners. Redux Toolkit is written in TypeScript and designed for a good Redux experience. And a lot of that is thanks to my co-maintainer, Lenz Weber. Redux Toolkit is good for all Redux users, whether you've been using Redux since 2015 or just getting started with it today. So let's talk about the APIs that are included. And the first one is configureStore. Now, with the original Redux createStore function, you'd usually go through several steps in every single project that you would set up. You would want to combine the reducers, you would want to add middleware, probably the Thunk middleware, maybe a couple more. You'd want to set up and configure the Redux DevTools extension, maybe pass in some extra logging setup, something like that. So configureStore was designed to do basically all of these things out of the box. When you call configureStore, it's going to automatically set up the Redux DevTools extension, automatically add the Thunk middleware. You can even pass in an object full of slice reducers, and it'll call combine reducers for you. You'll note that it actually takes a single parameter that is an options object instead of multiple separate positional parameters. So it's easier to see what you're actually passing in. And middleware and store enhancers can be passed in as arrays. Now, you also still have the ability to do all the customization that you ever would have done with createStore. You can still call combine reducers yourself. You can modify the middleware, configure the dev tools, pass in the initial state. All the options are still there. It's just easier to read and see what you're actually passing in. And the default usage is just a single function call, provide the root reducer, and it gives you good settings out of the box. Now, I said earlier that immutable updates are really hard, and accidental mutation has always been the number one cause of bugs with Redux applications. And frankly, immutable updates are very hard to write and read. A typical update has a whole bunch of nested spread operators and some map statements and concats. And there is a really, really cool library called Immer from Michelle Westrate, the author of MobX. And the way this works is you call this function that's normally known as produce. You pass in your original value as the first parameter. And the second parameter is a callback that gets what looks like this exact same value as its argument. And inside of there, it is safe to actually mutate that value. And Immer uses ES6 proxies to wrap the original value and track all of your attempts to modify and mutate that object. And when you're done, it replays all those updates and returns a safe, correctly updated, immutably updated result. So these two statements are equivalent. So you can either write a whole bunch of nested spread operators, or you could just write a single line of mutating state updates, and you get the exact same result. So Immer can drastically simplify immutable update logic. So One of the common complaints about Redux was like, apparently a lot of people really don't like switch statements. And so everybody was writing their own utility to have an object lookup table where the keys were the action string types and the values were reducer functions that would handle those updates. We even had one of those in our docs for years. So one of the first things we added to Redux Toolkit is a function called createReducer that is an implementation of that object lookup table example. But the really nifty thing is that it uses immer internally, so your reducer functions can mutate the state, and it actually works correctly and returns immutably updated results. Now, the important thing to remember is that this magic only works if you're using our createReducer function because it has immer inside. Otherwise, this really would end up mutating the state. We also have a function called createAction, which is sort of like createAction creator, I guess. So you pass in a string action type, it makes the action creator function, and then by default, whatever you pass in as the argument gets turned into the action.payload field, because that's a very common convention for organizing Redux objects. By default, it overrides the toString method so that you get back the action type string. Also has it as a field here, and the createReducer method actually lets you use these action creators in a builder syntax to say, handle when this action is dispatched, run this reducer as a result. But most of the time, you're not actually going to use createReducer or createAction in your own application code. And that's because what really matters is just writing the reducer functions. Like, you shouldn't have to spend a lot of time thinking about the action type strings or the action creators. You really should just be able to write reducers and have that logic and not worry about the rest of it. And that's why the core of Redux Toolkit is a method called createSlice. And the way this works is you provide a name field that's a string, some initial state value, and then an object full of named functions for the reducers. And you'll notice that these are once again able to mutate the state because this actually uses immer inside. And for every one of these case reducer functions that you provide, it's going to automatically generate action creators corresponding to those reducers. And from there, you can dispatch the action creators, same as if you'd written it yourself. And this makes it really easy to organize your code using the single file ducks pattern, where we have named exports for the action creators and then a default export for the reducer. createSlice also has the ability to handle other actions that were defined outside of itself, such as from thunks or other action creators. And it actually gives you some pretty powerful capabilities for matching against different actions as well. We've always suggested using the reselect library for writing memoized selectors. And Redux Toolkit doesn't do anything new or different here, but because reselect is so widely used, we automatically re-export createSelector itself, just so you don't have to manually add that package. We've always taught a standard approach for making async requests for data from the server, and that is that you write a thunk function, you dispatch some kind of an action before the request so that you can update loading state and maybe show a spinner. You make the request and then dispatch either a success or failure action after the request is done. And so because this is such a common pattern, Redux Toolkit includes a function called createAsyncThunk that abstracts this process for you. So you pass in a string action prefix and some function that just makes a request and returns the data that we care about. And it will automatically generate the action types, the action creators for you. You can handle those in a slice. And when you dispatch the thunk, it automatically dispatches the actions before and after the request. So again, not inventing new concepts, just simpler approaches for stuff that we've already done. Another example is this idea of normalizing state. We've always taught that it's useful to be able to store items with IDs in a lookup table where the keys are the IDs and the values are the items yourselves. And that makes it easy to look up any given item by its ID. And so we've always taught this pattern, but we never had any code that actually helped with that process. So Redux Toolkit has an API called createEntityAdapter that helps provide pre-built functions for doing CRUD-style operations on a normalized lookup table of data. So you can use these methods any way you want. You can either use them as a standalone reducer function in response to some action, or you can use them as mutating style helper functions inside of a createSlice reducer. It also has the ability to generate selectors that either retrieve the list or retrieve a single item, and it can even do some built-in sorting of data as well. Now, what we've seen over the years is that there's been a bunch of different add-ons and ecosystem libraries for side effects, but the most common thing that people do with side effects is fetching data from the server. And what we've really seen is that the entire React ecosystem has shifted from caring about state management to caring about data fetching and caching of server state. So last year, we introduced RTK Query, which is a complete purpose-built data fetching and caching solution designed for Redux applications. It fully abstracts the data fetching process. The idea here is that you define an API, which is kind of like a super powered slice. You provide a base URL, and you define one or more endpoints. Now, in this case, our endpoint is going to be fetching data for a single Pokemon based on its name. So we take the name as an argument, we return the rest of the URL string. Ultimately, it'll end up combining it with the base URL. And you'll notice that this automatically generates a React hook based on the name of the endpoint. And if I call that hook in a function component, it's going to give me back fields for the data and my loading state. It'll automatically trigger the request, update my component as the loading state changes or as the data comes back. And all that work is done for me. I didn't have to write any thunks or reducers or effects or selectors to get that data. Now, like the rest of Redux Toolkit, RTK Query's core is UI agnostic, and you can use it with other frameworks like NGRX or Vue or Svelte, but we have this React integration included as well. It's also not specific to REST APIs. We've got examples of integrating with GraphQL and other async functions, and so this can replace the need to write any data fetching logic yourself in a Redux app. So typically you'd have one API slice per server and a bunch of different endpoints. We designed it to have a non-normalized cache. So every response is just cached separately, no sharing of data. We also have some very powerful and unique features, like the ability to write cache lifecycle methods and do things like streaming updates from the server over a WebSocket. Another thing that we've seen people do over the years is write code that is reactive, code that listens to actions being dispatched or changes in state. And for years, the most common ways to do this were add-on libraries like Redux Saga or Redux Observable. And those are very, very powerful tools, but frankly, they're too powerful. Most Redux apps don't need that. And we wanted to include something in RTK that would solve that same use case. So we've introduced a new add-on called the RTK Listener Middleware. And it's designed to solve the same use case as Sagas or Observables, but with a smaller bundle size and a simpler API. So it is pretty powerful. You can do most of the same things that you could do with Sagas, but hopefully it's a lot easier to learn and use. It's also built on async await, which is a much more common paradigm that more developers understand. Listeners can decide when to run by listening to specific action types, matching against a range of action types, or even providing arbitrary comparisons, which allows you to do things like cases where certain state fields have changed. We do have primitives for allowing you to run longer running async workflows, like being able to pause until a promise resolves, wait until a certain action is dispatched, or even forking off child tasks to do additional work. So it's a very powerful tool, and I've been very happy to see the way that the community has started making use of it. RTK also includes some built-in safety checks. I said earlier that the most common bug in Redux apps has always been accidental mutations. So Redux Toolkit includes a built-in mutation detection middleware out of the box and automatically turns it on in development mode. We also check for the common mistake of accidentally including non-serializable data, like class instances of some kind. So what does it look like if we're using all this with TypeScript? We've really tried to design this in a way that it's easy to use TypeScript with Redux and Redux Toolkit today. So the typical setup is you create your store, and then you infer a root state type and the type of the store's dispatch method from that store object. From there, we provide some copy-paste examples of creating typed React Redux hooks that already have the state and dispatch types baked in, and then we tell you to use those everywhere in your application. And this avoids cases of, adding more slices to the store and not remembering to update the state types, or cases where the built-in React Redux hooks don't recognize thunks. In your application, you would write a slice file. You would define a state type for that slice, set up the initial state using that type, pass that to createSlice. And then inside the reducers, you just declare that this is a payload action and give the type of the payload field. From there, RTK will carry those types through so that the action creators have the correct types applied, and you would use those in the components. We have templates available for Create React App, both plain JavaScript and a TypeScript template. If you look in the next.js repo, they have a with Redux template that has RTK already configured. We don't have an official template for React Native right now, but there are some unofficial templates floating around, and same for Vite as well. So, unfortunately, there are still a lot of people who are writing legacy Redux code. Now, part of it is that there's code bases that have been out there for years, but there's also a lot of people who are looking at really old tutorials, going through outdated courses, or in a lot of cases, going through boot camps that are still teaching old patterns. So earlier this year, I released Redux Core 4.2.0, and in that, I marked the original Redux createStore method as deprecated. And the idea for this was that we wanted a way to reach out to users who, frankly, are never going to look at our documentation, and they don't know that Redux Toolkit exists. So by marking this as deprecated, when you import createStore, there's just a visual strike through. There's no runtime warnings, nothing's breaking, we're not removing this at all. But this gives people a visual indication that something has changed. And when they hover over it and they see the tooltip, they get a link to our docs and an explanation that there is a newer, better way to use Redux. So to be very clear, we're not removing createStore. We're not going to break anything, but we do want everybody who's using Redux to actually be using Redux Toolkit instead. So if you don't like the warning, the best option is to switch to using Redux Toolkit. Definitely configureStore and createSlice, and then you can use all the other things as you actually need them or not. You can also import a new alias version called legacy_createStore, but we really recommend just switching over to Redux Toolkit. So, in summary, Redux Toolkit is the way to use Redux today, and we designed it to solve all the problems that people using Redux are facing. It simplifies store setup, eliminates accidental mutations, eliminates the need to write a lot of different code by hand, eliminates the need to write immutable update logic by hand, makes it easier to write your Redux code for a given feature in one file, has really good TS support, includes RTK Query for data fetching, and it is the way to use Redux. So we want everybody who's writing any Redux code at all to use Redux Toolkit. I've got links to some further information here. These slides are up on my blog, and hopefully this has been informative. And we hope that using Redux Toolkit makes using Redux simpler, easier, and a lot more powerful in your applications. Thanks.